All right, so we are going ahead and working through this question here. The reason this one's a little bit challenging is that we have two isosceles right triangles, but they are connected to each other. So on the surface, it doesn't seem like there's enough information. But since they're both right isosceles, if the bottom side length is x plus 2, that means that this is also x plus 2, which means that I don't have a name for the other two, we call the legs, the two congruent pieces, two same length pieces, sides there. So I'm just going to call this side y. And since this is also right isosceles, this is also y. Everything we're doing right now comes back to Pythagorean theorem. So I'm going to go ahead and write an equation for the left triangle in terms of Pythagorean theorem here. So I have x plus 2, so that quantity is squared, plus x plus 2, that quantity is squared, equals to the length of the hypotenuse, which is y squared. I'm going to do the same thing over for the triangle on the right. The two legs squared, so y squared plus y squared, equals to, and then the length of the hypotenuse squared, x plus 6 squared. Okay. So if I take a look at these two equations, if you have two variables, that means that you need to have two equations in terms of the same two variables to actually solve it. So if I look at these things, they both have x's, they both have y's. So you have a lot of different options here. One thing I'm going to do right now is I'm just going to take this whole left-hand side of this equation right here, and I'm going to plug it in to the other equation for y squared in both places. The point of that is that when I do that, I end up with a situation where I have only one variable left. Okay, so that's that first y squared. Remember, there's multiple ways to do it. This is just one of them, so I just want to share my thought process here. So I'm plugging in for the other y squared. And we can definitely simplify this thing, which we'll do in a second. And then the right-hand side stayed the exact same, with no real changes there. No change at all, actually. So here I need to go through and I need to expand and combine terms here. So over here I'm going to expand out all four of those things here. And they're all the same expression. So really what I'm going to do just to make life easier here, instead of having to do it 4 times, I'm just going to put a 4 out front. And then I'm going to write what one of those is expanded out there. Okay, so remember, the reason I'm doing that is because there's 4 of the same thing. They're all being added, so I can just do 4 times whatever that expression is. So x plus 2 times x plus 2 FOILs out to be x squared plus 4x plus 4. And if you have a hard time seeing that, take a minute and actually go ahead and expand that out. Do x plus 2 times x plus 2, FOIL it out, and combine those middle terms. On the right-hand side, I end up with x squared plus 12x plus 36. Now, on the surface, it doesn't seem like it's that much better than when we started with, but we have one equation in terms of one variable, so we are actually in a better place now. So to actually get this thing to work here, I need to go ahead and move everything to one side so I can combine like terms and start to solve it, factor it, however you want to do that. So I'm going to take this 4, I'm going to distribute it to all 3 terms there. I have 4x squared plus 16x plus 16 equals to, and then I have this x squared plus 12x plus 36. So what I just said a minute ago was I want to move everything to one side. And I'm going to go ahead and move it over to the left-hand side. It doesn't really matter which side. I prefer to move it to the left so that I keep, that didn't cross off. I want to keep my coefficients in that leading term positive. Just makes things easier most of the time. So subtract 36 over there. That's 36. And so from this thing, I end up with 3x squared plus 4x minus 20, and then I just have a 0 on the other side. So if you get that far, that's awesome. Like, that's really the main goal here. I'm really happy if you can get that far. Now, we're actually trying to solve this thing for what x is going to be. So to actually get this thing going here, I need to factor. It isn't easily factored because the leading coefficient is not a 1. So I can't do that kind of simple factoring you've done in the past here. So we have a couple different ways to do this. You can do quadratic formula. Maybe you know that. We're also going to take a look here at what I call the AC method. Really, what we're going to do is take the coefficient on the first term and multiply it by third, or the constant there. So that gives me negative 60. So the question now becomes, what are the factors of negative 60 that add together to give us 4? Now, I don't expect you to get that right off the top of your head. I actually took a little bit of time to go through that when I was actually going through this one. But if you actually write out all the different pairs and possible combinations, what you should end up with is that if you have 10x and 10 and negative 6 would actually make that work. And like I said, mess around with it for a bit if you don't get it right away. It's okay to take some time. So here it's positive 10x and minus 6x. This is also a procedure called splitting the middle term, because if you take a look, the only thing that's changed here is I just split 4x up into 10x and negative 6x. So if I combine them together, it's the exact same thing I started with. So from here, what I'm going to do is, actually, it's a little bit easier if I write the negative term first. You don't have to, but if you write it first, you don't have to worry much on the next part where we actually group them. What I'm going to do is here, I'm going to group the first two together and group the second two together. The thing I need to keep in mind here, it's a red flag here, make sure there's that plus symbol stayed in between them. If it's been a negative, that complicates things, so if I can write that negative first, I usually do. So now I'm going to factor out whatever I have in common for the first two terms. In this case, I have a 3 and an x. So if I factor that out, I have an x and a minus 2. For the next two, they both have a 10. I'm left with an x minus 2. You know you've done this correctly, or it can be factored if the remaining pieces here are the same. The x minus 2 is here. Okay? So from here, what I'm going to do is, I'm going to take an x minus 2 out of that first term. And so when I take that out of this term right here, I'm left with a 3x. And when I take it out of the second term, I'm left with just a 10. Okay? So now I have this thing factored. Okay? And what we can do from here is, once it's in factored form, you can set the individual factors equal to 0, as we've done previously, and then solve for x. The first one's easy. I'm going to add 2 to both sides, give me 2. And then here, I can go ahead and subtract 10 from both sides, and then divide by 3. Obviously, we're looking at a side length, so the negative doesn't work as an answer. So my answer here is just 2. Okay. This is a tough question. You know, this is only the second day of class, so I expect people to have issues with this, and we'll definitely go over in class. But hopefully this gets you thinking about where you're going to go with it.